This is a LabVIEW Beginner lesson where we make a heart rate monitor. This is lesson 4 where we add modularity and functionality. In lesson 4-4 we'll be compartmentalizing the internal parts of the processing module because we want to make it clearer for us later or for anyone taking over the code, and we want to make it easier to add any code later. And this will be clear why it's better when it's compartmentalized. So if we look into the process VI, we have different functions. Here, not much is happening, neither is here, etc. But here, it's kind of messy. It kind of goes a little bit here, it goes a little bit there, but it's fine. It's been fine for now, but now, at some point, we want to add complexity, and it's better to kind of clean it up now, and so it's ready for the complexity. So let's write a note of what we're going to do, because it's good to have this note anyway. So just take a note of what we want to do. So the first thing that's happening here is we add the waveform to our existing waveform, making that the select size we wanted, as we did in a previous lesson. The next thing we do is to filter the waveform. And then we calculate the heart rate. And at the end, we send the data. We can also do a little cleaning up. As we see, this says acquisition now, and this is no longer a part of the acquisition. So we could move this to the processing and rename them, so that is clearer too. The input, we will also make a prototype VI, which we will use for all of this, because all of them will need the process data cluster in, and this one and set the waveform size will also need new data in here. And since this will be going through a lot of VIs, we'll start by making this a typedef. That way, if we change anything later, we will easily see it. It's this bug with LabVIEW where it changes all the, or removes all the labels if you ever make the typedef later. I don't know why this is happening, but it is. And then we'll save that. Processing, and then we call it loop data. And let's go and fix these. So they're part of the processing now. And here we have filter waveform. Let's rename them and move them. The reason I do this is to keep track of who owns them and where they are. It will make it easier later on if we want to edit things, or you want to find your way around the application. And there's no problem that it says acquisition on it so far. It's just now we want to compartmentalize, we want to clean it up, we want to make it clear. So we're doing this now. And we'll rename this too and move it. And by changing this inside of LabVIEW, you could do it externally, but then you will get a lot of errors. Yeah, in that way, the whole application pays attention and kind of joins the change rather than you having to do it two places. LabVIEW is pretty sensitive to changing names and locations, so it's good to do that within LabVIEW. And now I've moved them. I've moved them also to the virtual folder to make that also clearer. And now we'll change the icon. And we'll do the same change here. We want our VI, next VI, to look similar, so we'll just copy it and then we'll modify other stuff. The reason I'm copying so much is just because I don't want to make the icons again, etc. So we can start by having the add waveform to this. This will be basically this VI just packed in a different way. Add waveform. We want our new type def, our new cluster, this one. Let's actually move these ones in here. And we want the loop data in here. And we want that to pass through, so we have this one here, which is the input. Oops. And we have the input here, we'll move here, and then we'll duplicate it, change to indicator, and then have it called out. We can also disconnect all of the terminals, as we will not need this one, but we will need the data in. We will no longer be needing the data out. And we'll map these. We can make this one required, the same with this one. We might not need any error in or out, but you never know. And it doesn't hurt to have them. Then we edit this one. And we can actually just delete it here. And we add the name, which is add waveform. Let's just delete the content, as we will not be doing the same. We will have the data going in here and then out again through an error. And we'll have a case just in case, because if there's an error, we might want to do nothing. We just want to quit. We don't want to ruin any existing procedure. And what will be happening in here is this. This will do nothing more advanced than using this VI, but it will sort it in such a way that the data will be correct here. And we need to unbundle some data here. So the raw data goes in here. The raw collected data goes in the slot bit underneath. And then out from it, we get our raw collected data. And we need a little bit more space. So here we take samples in seconds. So we want to also take this here. And now this function adds the row collect the data and puts it with the new data, and then makes our set size waveform and pushes it out here so it's ready for the next process. And that's the add waveform to existing. I'll just make the VIs before I implement them, as that will be quicker. The next part we'll add the filtering waveform, but we already got the VI called filtering waveform, which filters the waveform. And this does it in quite a simple way. There's no fancy things here. So what we'll do first is call this one, just add simple filter, and also change the name accordingly. It's probably better names for this, but I couldn't think of any better names, so this is the names we've got. And then we'll open another copy of the add waveform, and we'll call it filter waveform here. And then we can edit this as we please. The error side will be the same, so we won't edit this. It's mainly this one, which is the difference. And here we want to simple filter the data. It wants the data in and the data out. So currently we're just putting it out and sending it away, but we want to store it in the loop data so that we can use it in another VI without having to unbundle or like keeping track of this. Keeping everything in a cluster makes it much easier for the input and output of a VI, as you don't need to kind of add an extra input for every data, which makes it a lot less of a burden. So let's go into loop data, let's copy this and say filter data. And let's move it to the top with everything else. Reorganize cluster. Let's put in space 1 after the raw data. And now let's continue with the filtering. I'll move this up here. Now filter data. Needs additional signals to remove. This might seem a bit unnecessary as we just put another VI within another VI without really doing anything, but this VI kind of chooses what data goes in here, while this one is just a simple filter and could be used anywhere. So now we made the filter, now we want the calculate heart rate part. And before we start making that VI, we'll just add another terminal here with that data. We call it heart rate, because again, we want to store it in the cluster. And we'll add it to the second place, so it's after the filter data. And now again, let's copy this one. Calculate heart rate. And we need to copy the functionality from here. We are no longer interested in the raw collect data, we are interested in the filter data, and we will write to the heart rate. Let's copy this in here. Now we have an actual use for the error wire. And inside the other functions, we might need it later, because the filter I set up and the adding way is just simple. It's just a simple function. We could, at a later date, add more complexity to it, like add a better filter, add a better way to add the data. And keeping the error here keeps that possibility open without having to change anything. And then lastly, the thing we need is to send the data. We'll just continue as we have by copying the last one. Call it share data. Delete this. And we want to copy all of this. Let's move all the unnecessary parts. We're not writing anything now, so we can just remove and rewire this one. What we are doing though is finding data, so we can just add another element to each of these. And here we have our raw collected data, so we can find that here and send it like this. Here we want our filter data, and we'll just add it like there. And lastly, we want our heart rate to go in here. And I'll move everything a little bit up so that we have room for the error wire. And lastly, change the icon. Yeah, it's getting a bit messy here because that's how it goes. And now we can basically delete everything here because we've compartmentalized it. That's why I did it in this order, because now we could just delete everything without thinking and move them in. And let's move this up here. And now let's add it. We need the add waveform, share data, filter, and then calculate heart rate. And we'll sort them in the order. So here is a problem when you just copy paste. If you're not paying attention, you will forget certain things and certain artifacts will be left in place. This could be a problem if you don't know about it and become sloppy. I always copy to save time, but this is the big thing that you have to worry about. In this case, it wasn't really a problem because it was nothing. But it could be a bigger mistake which you don't catch, and then you're in trouble. So what's happening here? We add the data, we filter the waveform, then we calculate the heart rate, and then we share the data. So we'll do our little trick again by marking everyone, holding control, pressing space, and while holding control, pressing W. Let's move this to the back. The only thing that took room in this event cluster was all of the things happening here. And since that's not happening anymore, we can try to make this one smaller. Okay, let's Control C and then make it a little bit larger than the minimum. And then we can add numbers just so they know the order. It kind of indicates what is happening. It might be a little bit useless, but we made it to remind ourselves of what we were going to do, like planning. And now we got this comment for free. Let's make this one smaller. Now we compartmentalized the processing. This didn't really, again, the compartmentalization doesn't really change any functionality, which is the point of it. It just makes it easier to see what's happening and also edit things later. In the next two lessons, we'll be adding functionality to processing, where this change will make it a lot easier.